This video explains the basics of acids, bases, and salts. An acid can be defined as a compound that releases hydrogen ions in an aqueous solution. Some properties of acids are that they taste sour, they're corrosive, they have a pH less than 7, they react with indicators, and some acids can produce burns, like battery acid. Some common acids that you might have heard of before are acetic acid, commonly called vinegar. Vinegar is used in food preparation like meat marinade and to preserve things like pickles. Citric acid is what's found in citrus fruits like lemons and limes and oranges. Hydrochloric acid is the acid that's in our stomach that digests the food that we eat. And sulfuric acid is the acid that's found in car batteries. Now let's talk about bases. The definition of a base is a compound that will release hydroxide ions in an aqueous solution. Some properties of bases are that they feel slippery if you get it on your skin. They taste bitter. They're also corrosive. They react with indicators like pH paper or litmus paper. And they have a pH greater than 7. Some common bases that you might be familiar with are ammonia. Ammonia is commonly found in cleaning products. Second one is magnesium hydroxide. This is called milk of magnesia, and it's used for upset stomach. Last one is sodium hydroxide. Sodium hydroxide is used in soap, drain cleaners, oven cleaners. Acids and bases can be defined in a couple of different ways. The first way we're going to talk about is Svante Arrhenius' definition of an acid. So Arrhenius said that an acid is any substance that forms a hydronium ion or H3O plus ion in an aqueous solution. So we see we have hydrochloric acid plus water gives us the hydronium ion plus chlorine. And you can see it's drawn out at the bottom too. So we've got hydrochloric acid, water, gives us the hydronium ion. Notice it has the positive charge because it's gained a positive proton. And then we have chlorine out here by itself. Arrhenius defined a base as something that will form hydroxide ions or OH negative ions in an aqueous solution. So we've got NH3 plus H2O gives us NH4 plus OH negative. So we can see that here's our hydroxide ion that's formed, and it makes it basic. Now if we look at Bronsted and Lowry, these were two scientists that defined acids as proton donors and bases are proton acceptors. Notice that we're not talking about the hydroxide ion anymore. We're just focusing on the hydrogen ion. So we've got HCl is our acid here, plus water, which in this case is taking the place of the base. And we end up with a conjugate base because it is given away that hydrogen ion, and then conjugate acid is the ion acceptor. Alright, so in general, when we're looking at a solution, if there's a high concentration of hydrogen ions, then it's considered to be an acid. So acid would have a relatively low hydroxide concentration. Conversely, if we look at a base, it should have a relatively high OH negative concentration and a low hydrogen ion concentration. So that's how you determine whether it's an acid or a base. Now we can look at whether the solution is strong versus weak. So if it's a strong acid or base, it's going to dissociate completely and contribute either a whole bunch of hydronium ions or hydrogen ions. If it's a weak base or acid, it's not going to dissociate completely and contributes few of these ions. So let's pause here and go ahead and pause the video and identify each of these characteristics, either they're characteristic of an acid or of a base. So go ahead and pause the video now. Really, pause it. Okay, so let's go over your answers. So for sour taste, you should have put A for acid. Number 2, produces OH negative ions in aqueous solutions. Well, we know that bases always produce the hydroxide ions, so we're going to put a B for base. Chalky taste, that's another base characteristic. Is an electrolyte. Well, both acids and bases produce ions, and we know that ions are what make a solution electrolyte. So for is it an electrolyte, it's both of them. And then number 5, produces hydrogen ions in an aqueous solution. We know that's a characteristic of acids. So we've defined what acids and bases are. Let's talk about indicators. So an indicator is an organic compound that's going to change color in the presence of an acid or a base. So we've got some different indicators listed here. So red cabbage juice is actually an indicator. Here's your red cabbage up here at the top. Buy it at the grocery store. pH paper looks like this. And we have tons of it. Litmus paper we've got 2 different kinds. We've got red litmus and blue litmus. So red litmus paper is going to turn blue when a base is placed on it, and it would look like this. And then the blue litmus is going to turn red or pink when an acid is placed on it, so it would look like this. Alright, and lastly is phenolphthalein. This is a solution that you would put in, it turns like a bright pink. I believe it's a pH of like 8 to 10. So it's an indicator for a base. Alright, we have another question. So which of these could be used to determine whether a substance is a base? So we've got A is thermometer, B is litmus paper, C a balance, D Bunsen burner. So thermometer measures temperature. That has nothing to do with the base, so let's cross that one out. Litmus paper. Well, we just talked about how litmus paper could be used as an indicator for acid or base. So let's hold on to that one. A balance. Balance is used to weigh things. That doesn't really have anything to do with whether a substance is a base, so we'll cross that one out. And then Bunsen burner. We know that a Bunsen burner produces a flame. We want to heat things up. And that has nothing to do with whether a substance is a base or not. So let's cross that one out too. So our correct answer is B, litmus paper. Let's talk about salts. So salts are formed when you combine an acid and a base together. They neutralize to form a salt and water. So you can see this is the basic equation for acid plus base. This is called the neutralization equation. So acid plus base yields salt plus water. There should be an arrow here. So, and then we have an example down here. We've got hydrochloric acid plus sodium hydroxide gives us sodium chloride, which is salt, and H2O, that's water. Some common salts are sodium chloride, which is table salt, calcium carbonate, which is chalk, and it's also used in antacids. And then we have sodium hydrogen carbonate, which is baking soda. Alright, last question. So a certain commercial product used for cleaning ovens must be handled with rubber gloves. The product is slippery and turns litmus paper blue. Probably contains, is it an acid, a base, a salt, or an isotope? Well, we know that, let's look at the problem. It says cleaning ovens, the product is slippery and turns litmus paper blue. These three properties are for a base. The only thing that an acid's not slippery, and it's not used in cleaning ovens, and it doesn't turn litmus paper blue, it turns it red. So it's not that. A salt, you can't indicate or use litmus paper for a salt, so it's not that. And an isotope, no. So it's a base. And that's it.